So now we are going to discuss about some specific trends in periodic table. We have previously studied about, and we have been known that the periodic table tells us about several chemical properties, physical properties, and properties of the compounds of every element. So instead of memorizing each and every property of element independently, we can get a general idea of the chemical and physical, as well as chemical and physical properties, as well as the properties of the compounds formed by the elements which we are using. So in that sense, and the period table tells us in general way about a specific element which belongs to a specific group or period by what we call as the trends or patterns. Now these trends are set across the groups and across periods. When it comes to the trends which are set across groups and periods, these involve trends of ionization energy, trends of atomic sizes, trends of electron affinity, and then so many others which we are going to discuss over here. So we are going to start with the trend of atomic size. Um, First and foremost, we need to understand that what is the size of an atom. Size of an atom cannot be determined even with the help of an electron microscope. Even if we are supposed to watch an atom size with an electron microscope, we need to, we can only view the interatomic spacing of the of atom with the help of electron microscope at maximum. But in order to determine what is the size of an atom, we can determine the atomic radius through which we can identify the the volume of the atom as well as the size of the atom by simply getting an idea of what is the radius of an atom. So atomic radii is a property which is measured in angstroms. It is got as units angstrom. We are known about angstrom, which is equal to 10 to the power minus 10 meter. And if we discuss the size of the atom in terms of angstrom, the atomic radius in terms of angstrom, we utilize the unit angstrom generally. And apart from that, if we come to talk about atomic radius, it has got a specific trend in our period table. In periodic table, generally the size of an atom, generally the diameter of an atom ranges from 10s power minus 18 to 10s power minus 90, while the diameter of the nucleus ranges from 10s power minus 14 to 10s power minus 15. So this is a huge difference. I mean, like the atom is 5 times bigger in radius than the nucleus, which is quite huge, no? So in that sense, the atomic radius varies in terms of angstroms. So let us just discuss how atomic radius varies in the groups and periods. If we talk about the periods, when we move forward in a period from left to right, we get to know that the number of atoms, the periodic number increases by one by the moment we move one time from left to right in a period. So as we move from left to right, the charge number or z increases, and as a result of charge number z increasing, the charge on the nucleus starts to increase, due to which the nuclear force of the atom is increased, as a result of which the outermost shell is attracted with strong electrostatic force of attraction, Coulomb force of attraction, by the nucleus, such that there is a strong electrostatic force of attraction developed between the nucleus and the outermost electron shell, due to which the high nuclear force causes to decrease the volume of the atom and ultimately increase its density, due to which we can say that as we move from left to right in a period, then the size of the atom decreases as a result of its increasing nuclear force, as a result of which the density of the atom is increased due to decreasing volume. Alongside which, if we talk about the concept of charge surface density is basically what we call as the density of charge present in the nucleus, density of charge present in the nucleus, which is found to be highest in lithium, because lithium has got a really small uh, size. So it has got a really small size, and within that small size it has got high nuclear force, due to which it is having the high charge surface density. But again, size decreases, atomic radius decreases from left to right, so we can consider in some manner that charge surface density follows the same trend as atomic radius, such that it decreases from left to right. But again, there are exceptions as well, which we are uh, you know so in that sense, it depends on the size. Charge surface density depends on the charge which is present on the surface of the nucleus, as well as the size of the atom as well. So in that sense, lithium has got a high charge surface density because of its small size and because of the high charge it possesses. Now, on the other hand side, if you talk about atomic radius in group, the atomic radius increases from top to bottom because of the addition of new shell. When we move from group, um, from top to bottom in a group, then from hydrogen to lithium, there is addition of an other shell. Let's suppose hydrogen has S, hydrogen has got K, then lithium has got, alongside K, there is an L shell, right? So due to the presence of L shell, there would be increase in the atomic radius, due to which atomic radius would be increasing in a group. Now, if we talk about ionization potential is simply what we call as the amount of energy which is released when the amount of energy, sorry, yes. So ionization potential, ionization potential or ionization energy, it is the amount of energy, it is the amount of energy which is required to remove one electron from the outermost shell of its atom. Now, this energy is, since it is energy, it is measured in joule. But since we are, discussing it in terms of uh, chemical matter, so we are going to utilize kilojoule per mole. Kilojoule, kilojoule per mole, right? So this is a unit, kilojoule per mole, which is utilized for ionization energy. And ionization energy which is required to remove electron from the outermost shell or the valence shell is known as the first ionization energy. First ionization energy. But if we talk about ionization energy which is present, the ionization energy which is required to remove electron from the second shell of the atom, or the second electron which is removed after the first ionization energy electron, then at that moment that electron, that energy required for the second ion, for the removal of the second electron after the removal of first electron in that atom, would be the second ionization energy. And whenever there would be the removal of the third electron after the removal of first and second electron from the outermost shell in the atom, then that would be considered as third ionization energy. If we generally talk about the ionization energy, then first ionization energy is believed to be the lowest, such that first ionization energy is less than second ionization energy, and second ionization energy is less than third ionization energy, which means that uh, first ionization energy is least and third ionization energy is the most. So in that sense, this is how classify ionization energy. When it comes to its trend is in such a manner that from left to right in the period the ionization energy increases because the charge number increases, due to which the attraction of the nucleus increases towards of the shell, due to which it is more difficult for the atom to remove the electron from its outermost shell. But if we talk about ionization energy from top to bottom, then it starts to decrease because of the addition of shells, due to which the nuclear force decreases on the outermost shell because of the increasing distance between the nucleus and the outermost shell, due to which the ionization potential is decreased and it is easier for the electron to be removed from the atom. Now, on the other hand side, if we talk about ionization energy, it is measured in positive. It is measured in positive. It is measured in a positive sign because energy is being absorbed in this case. If we talk about electron affinity is another concept in which it is the amount of energy which is required, which is absorbed. Sorry, it is the amount of energy which is released or absorbed when an atom accepts an electron. When an atom accepts an electron, then the amount of energy which is released or absorbed is known as electron affinity. Generally, the energy is released if it is the first electron affinity. If the first electron affinity is there, then first electron affinity is always negative, which releases energy. And the energies which are followed by first electron affinities, the second electron affinity, third electron affinity are all positive because they need energy, because they absorb energy to accept that electron, right? Since it is a non-spontaneous process. And first one is a spontaneous process if it is occurring in terms of chemical reaction. Now, first electron affinity is the one in which the electron is being first electron is being accepted. But if the second electron is being accepted, that would be considered as an absorptive process. Absorption will occur, positive sign of energy would be there, and the electron would be difficult to be accepted because electron affinity would be higher than the first electron affinity, due to which this second electron affinity is considered to be of higher energy and thus absorbs energy. Likewise, third electron affinity would absorb more of the energy and would be a non-spontaneous process in which this would be an endothermic reaction, right? So in this sense, this is how we classify electron affinity. Now, when it comes to the trend of electron affinity is having its trend in the following way that from left to right, electron affinity increases because of increase in the charge number, due to which there is an the increase in the charge number, due to which there is an increase in the nuclear force, due to which it becomes there's an increase in the nuclear force, due to which it due to which the electron affinity is also increased, or the amount of energy released, electron affinity is also increased. But on the other side, if we come from top to bottom, the electron affinity decreases because when we move from top to bottom, there's addition of shells, due to which the distance between nucleus and outermost shell increases and the nuclear force ultimately decreases, due to which it becomes more difficult to accept that electron, and thus in that sense electron affinity decreases, or the ability to accept the electron is decreased. Now, if we talk about uh, what do we call it, the trend of shielding effect, one important factor that contributes to decrease in the electron affinity and ionization potential in the group is shielding effect, such that when you know we move from top to bottom in a group, then there's addition of shells basically causes to shield the effect, they cause to shield the nuclear force which is being transmitted towards the outermost shell, such that at the second last shell, let's suppose if we talk about an atom, let's say if we talk about an atom which has got two shells, right? And if we are moving in a group, and we are moving in a group from top to bottom, and we are in the, let's suppose, in the third period, so we've got another shell which is the third shell. Now, like, ionization potential would be decreased, as well as electron affinity would be decreased in the third shell, because the first two shells would be having the electrons which would be shielding the effect of the nuclear force which is reaching over the outermost shell. So in that sense, This shielding is occurred by additional number of shells which are created in the pathway of nucleus in the outermost shell, due to which this shielding effect is considered to be affecting the value of what we call as the value of ionization potential electron affinity. Now in group the shielding effect increases, and in period the shielding effect decreases, because in period there is no addition of shells, and in group there is addition of shells, so there is a good increase in top to bottom. Apart from that, if we talk about the ionic radii follows the same trend as atomic radii, because um, ionic radii is also dependent on the same conditions which we have studied in atomic radii. The only difference which I would like to highlight over here is that an atom which loses an electron becomes positive ion cation, right? And the one atom which gains an electron becomes a negative ion anion. So whenever there is a loss of electron, that the atom becomes a cation, and that loss of electron basically causes that atom to lose the shell as well. For example, let's take the example of sodium. Structure of sodium is in such a manner that in the outermost shell there is only one electron, and when it loses one electron, it causes to gain a causes to gain a positive charge, and thus become a monovalent cation. That monovalent cation which is formed over that, that monovalent that monovalent cation is basically that monovalent cation is basically this monovalent cation is basically what we call as less in size, because in the outermost shell there was one electron which was given by sodium, due to which the outermost shell had no electrons, and thus the outermost shell was no more over there, due to which the outermost shell was finished as a result of loss of electron, due to which the ionic the radius of that atom was decreased, so such that when atom becomes a cation, its atomic radius is decreased, and when atom becomes an anion, its atomic radius is increased. So if we are supposed to arrange it in a manner, then a negative is greater than a in terms of radius. A negative is greater than a is greater than a positive. So this is what we call as the ionic radius. Apart from which, when we talk about some other characteristics as well, for example, electronegativity. Electronegativity is basically the ability to attract the electron pair in a chemical bonding towards the atom. So if we talk about electronegativity, it is increased from left to right in a period, and is decreased from top to bottom in a group. The reason behind it is that from left to right, the charge number is increased as a result of increase in charge number. As a result of increase in charge number, there is as a result of increase in as a result as a result of increase in charge number, there's an increase in the nuclear force, due to which the attraction of the electron pair towards the atom is also increased, due to which electronegativity is also increased. But if we move down from top to bottom, then the electronegativity is decreased because of addition of shells, due to which the distance between nucleus and outermost shell is increased, due to which the nuclear force is decreased, and thus the electronegativity decreases as well. So this is a basic concept. We are going to discuss about a few more things, a few more phenomena and specific trends in the next video.